The James Webb Space Telescope's recent discoveries of Mercury have caused a wave of excitement and enthusiasm in the scientific community. Known for its proximity to the Sun, Mercury has long attracted attention due to its unique and enigmatic properties. Observations by the James Webb Telescope have revealed new information about this small, rocky planet, challenging our previous understanding and promising to change scientific theories. Mercury, despite its small size, is a very complex planet. Proximity to the Sun can be a harsh environment, but this harsh environment benefits from many beautiful features. Recent observations made by advanced spacecraft and advanced telescopes have revealed the presence of scattered diamonds on Mercury's surface. This discovery alone is amazing. Diamonds were previously thought to be unable to form in such a hot environment. The discovery is just part of a larger story that suggests Mercury's core is massive and unusual, defying previous scientific predictions about the structure of the universe's interior. Previous missions are the basis for these revelations. Mariner 10, launched in the 1970s, was the first spacecraft to visit Mercury. Close-up images show a planet characterized by a rough surface filled with craters and strange bulges, reminiscent of the Moon. Mariner 10's observations also revealed that Mercury has a surprisingly large magnetic field, much wider than previously thought. These first observations began to challenge existing ideas about the composition and dynamics of Mercury's interior. The next Messenger mission, launched 31 years after Mariner 10, provided a deeper understanding. Unlike its predecessor, Messenger was designed to orbit Mercury, providing a continuous and detailed view of the planet. During the mission's lifetime, Messenger took nearly 200,000 images, revealing never-before-seen features and increasing our understanding of Mercury's surface and interior structure. Among the most famous discoveries was the discovery of unexpected levels of magnesium and manganese on the dark side of Mercury. This discovery led to increased scientific interest in the processes by which the concentration of the elements increased. In addition, the Messenger data showed that Mercury's magnetic field is stronger in its northern regions, adding another layer of complexity to our understanding of its magnetic properties. One of the most surprising features of Mercury is its extreme temperature variability. Because of its thin atmosphere, which has little ability to retain heat, Mercury's temperature rises to 806 degrees Fahrenheit during the day and drops to -292 degrees Fahrenheit at night. This large temperature change indicates the planet's lack of atmospheric protection and its adverse environmental conditions. However, recent studies have revealed surprising trends. For example, in 2012 Messenger found evidence of past volcanic activity, including explosive eruptions, contradicting previous beliefs that Mercury was inactive. The discovery of water ice in permanent craters at Mercury's poles in 2020 adds another layer of intrigue. Sheltered from the Sun, these craters are cold enough to hold ice despite Mercury's proximity to the Sun. The presence of water ice on such a fiery planet raises interesting questions about the planet's ability to support past conditions. Can these icy regions live like real humans on Earth? This question opens up exciting possibilities for understanding how life can survive under such planetary conditions. Looking ahead, the Bepicolombo project, a joint venture between the European Space Agency and the Japan Aerospace Exploration Agency, is scheduled to reach Mercury by 2025. Bepicolombo aims to gather information about the surface and history of Mercury. Despite the challenging environment of Mercury, which is characterized by rapid flow and slow rotation, Bepicolombo is very aware of the structure of the planet and its inner processes. Mercury's rotation and cycle create unique challenges. A day on Mercury, defined by a complete revolution on its axis, takes 176 Earth days, while a year, or one revolution around the Sun, takes only 88 Earth days. This means that the day on Mercury is longer than the year. This different pattern of rotation and orbit results in a different perspective. If you're on Mercury, the Sun will rise, stop, and retreat across the sky before continuing. This phenomenon occurs because of the slow rotation of Mercury compared to its fast orbit. The reason for Mercury's slow rotation is related to tidal locking. Over billions of years, the Sun's influence slowed Mercury's rotation. Unlike the Moon, which keeps time on Earth and shows only one eye, Mercury shows a 3:2 orbital resonance. This means that for every 2 revolutions around the Sun, Mercury makes 3 revolutions on its axis. This unique cyclical dynamics contributes to the most extreme weather conditions in the world, with extreme temperature changes between day and night. Mercury's atmosphere, or rather, its exosphere, is another part of interest. The exosphere is very thin and a diffuse collection of particles that are constantly drifting into space. This thin layer is filled by the solar wind, radioactive decay, and micrometeor impacts. Messenger data revealed that Mercury's surface has more water vapor than previously thought. This water vapor may be the result of hydrogen from the solar wind interacting with oxygen in Mercury's rocks. The combination between Mercury's fast orbit and slow rotation affects its magnetic properties. Despite its small size and slow rotation, Mercury has a large magnetic field, although it is weaker than that of Earth. This field is created by unique internal motions in the liquid metal core, influenced by the unique rotational and orbital properties of Mercury. A weak magnetic field shields Mercury's surface from the solar wind, keeping the atmosphere from thinning. The complex relationship between Mercury's fast orbit and slow rotation creates interesting features on the surface. Certain areas known as warm poles can experience extreme heat due to prolonged exposure to the Sun. In contrast, the regions near the poles remain in shadow and remain icy despite Mercury's proximity to the Sun. This thermal shock may contain other materials or organic compounds, suggesting that the icy regions of Mercury may contain only liquid ice. The exploration of Mercury was accompanied by challenges due to its unique orbit and rotation. The spacecraft had to undergo complex maneuvers, including multiple flybys of Venus and Mercury itself, to adjust its speed and trajectory. For example, the Bepicolombo mission uses these birds to slow down and enter orbit around Mercury, showing how difficult it is to study this complex world. Further studies of Mercury's history have yielded many surprises. For a long time, Mercury was thought to be sleeping. However, evidence from Messenger shows recent volcanic activity, including the discovery of bright craters and volcanoes that indicate ongoing agricultural activity. The discovery of a large, ancient volcano beneath Mercury's surface suggests that early volcanism played an important role in shaping the planet's surface features. In addition, studies have shown the presence of trace elements such as sulfur, potassium and sodium on the surface of Mercury. These materials, which do not vaporize at high temperatures, may have reached Mercury through cometary or asteroid impacts after the formation of the planet. This theory adds another dimension to our understanding of Mercury's formation and history. The discovery of nitrogen beneath Mercury's surface is remarkable, discovered in 2022. This nitrogen is the remnants of an ancient, dense atmosphere that has disappeared over time due to strength of the Sun's rays and heat. The discovery opens new avenues for investigating Mercury's past climate and its ability to support life in some form. Mercury's unique properties extend to its internal structure. Unlike Earth, which has a solid inner core surrounded by a liquid exterior, Mercury has a mostly liquid and partly solid interior. This configuration, confirmed by the Messenger gravity probe, is important for generating Mercury's magnetic field. The solid inner core, which makes up half the volume of Mercury's core, contributes to the planet's magnetic properties. In addition, Mercury's thin mantle, which is only 260 miles thick, affects its geology in heat distribution. The thickness of the cloak is very different from Papa's cloak, which is very thick. The thin mantle contributes to the properties of Mercury and its ability to handle internal heat. As scientists continue to unravel Mercury's surface and subsurface, new discoveries are challenging previous assumptions and revealing more about the planet's history and evolution. For example, the discovery of organic matter in the polar ice caps of Mercury indicates that complex organic molecules, similar to those that contributed to the origin of life on Earth, may still exist. This can add a new layer to the study of Mercury. The mysterious land of Mercury, a large and circular area of hills and valleys, is also mysterious. This region near Mercury's south pole, discovered during the Mariner 10 mission, is thought to have been formed by large earthquakes and motions in the planet's orbit. Recent studies, including work by Dr. Amir Khan, have used messenger data to investigate the interior composition of Mercury, revealing a liquid outer and solid inner core. To your dad, but there are big differences in size. Of course, Mercury is a planet of wonder and mystery. Being small and close to the Sun does not diminish its complexity. Further exploration and study of Mercury promises to provide more information about the Earth's history, internal structure, and ability to host elements. As we look forward to future missions and discoveries, Mercury will undoubtedly continue to fascinate scientists and challenge our understanding of planetary science and the structure of the solar system.